Section 5.3 is on polynomial functions, and our objectives are to recognize and evaluate polynomial functions and add and subtract polynomial functions. A polynomial function of degree n is defined by f of x equals a sub n. Now this a sub n is simply a coefficient, and a sub n, just saying, cannot equal 0. A coefficient is a real number. It could be a 5, it could be a -2, it could even be a fraction. So a to the n times x to the n, where n is a power, and n is going to be the greatest power. And then followed by the remaining terms in descending order of the powers. So a sub n is a coefficient, and x to the n is the variable raised to the nth power, plus a sub n minus 1, the next coefficient, times x to the n minus 1 power, and so on until you get to the last term with no variable, so we call that the constant term. And another part of the definition is that the power of n has to be a whole number. In this example, we have f of x equals 4x to the third minus 5x squared plus 7, and we want to find each value. F of 2 is found by replacing each x in the polynomial function with the value of 2, and then using the order of operations to simplify. So we get 4 times 2 to the third power minus 5 times 2 to the second power plus 7. Following the order of operations, you do exponents before you do multiplication and division. So we get 4 times 2 to the third power, which is 8, minus 5 times 2 to the second power, which is 4, plus 7. Now we can do the multiplication step. 4 times 8 is 32, minus 5 times 4 is 20, and then add 7. And with the addition and subtraction, we go from left to right, beginning with 32 minus 20, these two first, to get 12, and 12 plus 7, we get 19. So the 2 that we plugged into the function, we call this as our input for the function, and the number that we get out is called the output. We can think of all of the input values as values that are part of the domain, and all the output values are values that are part of the range. The input values are typically represented as x values, and the output values are typically represented as y values, and they can be graphed on a piece of graph paper. Now these two separate concepts, input, output, domain and range, x values and y values, one way you can keep those straight is by using the following. We have domain is your input, which are your x values, the dix, and then your range is your output or your y values. So that's just something you can kind of keep in your notes and refer to often. Your domain is your input, your x values, your range is your output, and your y values. For part B, we want to find the value of f of -3. We're plugging in -3 where we see the x in the function, and then using the order of operations to simplify. So f of -3 is found by replacing all of those x values with -3. So 4 times -3 to the third power minus 5 times -3 to the second power plus 7. Now we can use the order of operations, making sure that we do the exponents before multiplication. -3 to the third power is -27. -3 to the second power is +9. And now the next step in the order of operations is to multiply 4 times -27 to get -108. 5 times 9 to get minus 45, and then plus 7. And then finally the addition and subtraction, you go from left to right to get negative 153 plus 7, and then our final answer is negative 146. So again, our negative 3, that's our input, that's your domain, that's part of your domain, it's your input, it's your x value, and what you get out is part of the range, that's your output, your y value. So the fact that we're evaluating a function at negative 3 and getting out negative 146, that can be expressed as an ordered pair, negative 3 for x and negative 146 for y. We can add and subtract functions. If f of x and g of x define functions, then this notation can be used to represent f plus g of x, which is found by taking the entire f of x function and adding the entire g of x function. The f minus g of x, this notation here, that's what you want to look for whenever you see that f minus g in parentheses and x. That is another way of saying take the entire f of x function and subtract the entire g of x function. In each case, the domain of the new function is the intersection of the domains of f of x and g of x. For the polynomial functions defined by f of x, which is our 2x squared minus 3x plus 4, and g of x, which is x squared plus 9x minus 5, we want to find the sum and the difference. So our f plus g of x is found by taking f of x plus g of x. Let's write that as the entire f of x function, which is 2x squared minus 3x plus 4, and then plus the entire g of x function. You can even put these in parentheses to get x squared plus 9x minus 5. And when we're adding these polynomials, like we did in the last section, we are combining like terms. So we have the first 2x squared and we're adding another x squared to it. That's going to give us 3x squared. And then we add the linear terms, the minus 3x and the plus 9x. We're adding that to get a positive 6x. And then we're adding the last terms as constants, 4 plus a negative 5 to get minus 1. So this is how we can write our answer for the sum of f of x and g of x. Or, written in this way, in parentheses, f plus g of x. Let's find the difference. And finding the difference, we take the entire f of x function, which is 2x squared minus 3x plus 4, and we're subtracting the entire g of x function, which I'm going to put in parentheses so that I am careful about any errors with my signs. I am subtracting the entire quantity. I'm subtracting each one of those terms. So I want to make sure I'm taking into consideration that minus sign. So this can be written as 2x squared minus 3x plus 4 minus each of those terms to give me minus x squared minus 9x, and then that minus a negative 5 is a plus 5. Now I can combine like terms, beginning with the squared terms. The 2x squared and the minus x squared, those are like terms, so you can combine those into x squared. The minus 3x and the minus 9x are also like terms, so you can combine those to get minus 12x. And then finally, the constant terms, the plus 4 and the plus 5, we add those to get 9. So that is how we write our final answer, which is the difference of the two functions, f minus g of x, which is f of x minus g of x. For the polynomial functions defined by f of x equals 4x squared minus x and g of x, which is equal to 3x, we want to find each of the following. Now we can find f plus g of x by finding f of 5 plus g of 5. Let's find the value when you plug 5 into the f function and the value when you plug 5 into the g function. So let's write our notes here. F of 5 is equal to 4 times 5 squared minus 5. And by using the order of operations, we get 4 times 5 squared, which is 4 times 25, minus 5. And then again, the order of operations, we multiply next to get 100 minus 5, and that is equal to 95. So that is the value when you plug 5 into the f of x function. Now we want to also find out what the value is when we plug 5 into the g of x function. So our g of 5 is equal to 3 times 5, and that's 15. So our final f of x plus g of x or f of x, our f of 5 plus g of 5 is 95 plus 15, which is equal to 110. Which is our final answer. For the polynomial functions defined by f of x equals 4x squared minus x and g of x equals 3x, we want to find each of the following. Let's find f minus g of x and f minus g of 3. Here we're going to have two parts to our answer. We have f minus g of x, first of all. F minus g of x is the same thing as f of x minus g of x. So let's take our entire f of x function, which is 4x squared minus x, and subtract the entire g of x function, which is 3x. By combining like terms, we see that the only two like terms are this minus x and a minus 3x. So we can simplify that to get 4x squared minus an x and minus another 3x is minus 4x. So our f minus g of x can be written as 4x squared minus 4x. That would be our answer for the first part of this example. For the second part, we want to find f minus g of 3. Now, f minus g of 3 can be found by taking f of 3 and subtracting g of 3. So if you plug 3 into the f of x function, you get 4 times 3 squared minus 3 is equal to 33. And when you plug 3 into g of x, you get 9. So 33 minus 9 is equal to 24. That's found by plugging each 3 into each of the original functions and then subtracting. However, what can be done is we already have simplified this form for f minus g of x is this quantity here. So we could take this simplified version, f minus g, and plug in 3 into the result. I'm going to plug in a 3 here and a 3 here. And when we do that, we get 4 times 3 squared minus 4 times 3. And that is 4 times 3 squared, or 4 times 9, which is 36, minus 4 times 3, which is 12. And we see that we end up with the same answer, 24. Now we will be looking at some basic polynomial functions. The simplest polynomial function is the identity function, and it is defined by f of x equals x. Now, x is our input. That's part of the domain. So domain is the input values, and those are expressed as x values. The range is your output values, and that can be expressed as the y values. So when you are evaluating this function, f of x equals x, you plug in these input values for x, and what you get out are the output values of y. So when you plug -2 into this function, what you get out with the identity function is you get out identically the same thing as what you plugged into the function. And that ordered pair of -2, -2 can be found on the graph at this point right here. And each of these x values that you plug into the function correspond to a y value that you get out of the function, and then those coordinates, those xy pairs, are represented as points on the identity function graph. Now, the x value is your input, your domain, your y values are your output, your range. And recall one way to remember those is the D for domain, I for input, X for X values, and the range is R, O for output, and those are your Y values. The squaring function is also considered to be a basic polynomial function. The function is defined by f of x equals -x squared. Now, whatever you do for the input, whatever input values you plug in, for example, -4, to get the corresponding output value, you're going to square that. So -2 to the second power is +4. So that corresponds to the ordered pair and a point on the graph of -2, 4. Each of these input values corresponds to an output value, and this is the result are points that are on the graph of the basic squaring function. Now, what we'll see in later sections is that any graph, or many of the graphs, are taking one of these basic polynomial functions and transforming them. The cubing function is defined by f of x equals x to the third power. Now, the domain, what we're plugging in here to our function f of x equals x cubed, whatever we plug into this function, we get the output value by raising that value to the third power. And -2 to the third power is -8. So that corresponds with a point that's on the graph of the basic cubing function. And again, the remaining points, when you're sketching graphs and making a table of values on your own, I suggest starting off with some negative values and some positive values and 0. And then once you get an idea of what the points are doing with those, you may need to make adjustments and graph even more to get a sense of the overall shape of the basic polynomial function.